In Lesson 7 of Topic B, we are solving multi-step equations. We're given a diagram where line AB intersects line ED at point C. We are asked to write an equation to determine the value of x. The first thing you want to do is look at the diagram and recognize that vertical angles are congruent. Then we're going to want to define what we're talking about here. So BCE is 2x plus 8, and DCA is 4x minus 20. It's a little hard for me to record the whole screen. The diagram's kind of big. So if you would please just refer to the book on page 111. And we're going to leave a space up here for our solutions. So we know if two angles are vertical angles, then they are congruent angles, and if angles are congruent, then they have equal measure. So we can say that the measure of angle BCE is equal to the measure of angle DCA, and then 2x plus 8 is equal to 4x minus 20. Now I can subtract 2x from both sides, and the reason why I'm moving the 2x over is I'm looking at the coefficient or the number in front of the letter on both sides. So I have a 4 on the right, a 2 on the left. I'm moving the smaller one over. It doesn't really matter if you move the larger one over. Just know you'll have to divide by a negative at the end, which absolutely has no bearing on this problem, but if it were an equality, as you know it would. So 8 is equal to 2x minus 20, and I'm only doing one step at a time. So I'm not moving the numbers over in the same step that I'm moving the terms with the variable. So now I'm going to add 20 to both sides, and I get 28 equals 2x. Then I divide both sides by 2, and now I know that 14 is equal to x. So I want to check my work. Wherever there's an x in the original equation, I'm going to substitute the 14. So I have 2 times 14 is 28, plus 8, that's 36, and 4 times 14 is 56, minus 20, that's also 36. So that is a true statement. My work is correct, and now I know that angle BCE is 36 degrees, and DCA is 36 degrees. On the next page, we are given properties of equality to look at and asked to complete the table. So in the addition property of equality, what that is asserting there is if you have an equation like A equals B, then if you add C to A, you also have to do that to the other side. For example, if the same number is added to the expressions on each side of an equation, then the equation still is true, it's still balanced. For example, in this first one, and I'm going to take each of these separately. Here, they're showing adding the constant, the number, 20, to both sides of the equation. And in the next line, they're showing moving the variable term, or the term with the variable, on both sides of the equation. So whatever you do to one side, you have to do to the other. That's just the rule. And that same rule applies to multiplication and or division. So in other words, if you have the equation A equals B, then if you multiply A times C, you also have to multiply B times C. So whatever you do to one side, you have to do to the other. So here they're multiplying the original equation of 2x equals 28, both sides by 1/2. So now let's look at solving some equations. In number 3, they show 27 minus 3a equals 8a plus 5. So what I'm going to do to begin with is address the term with the variable. So since it's a negative on this side of the equation, I'm going to add it to both sides. The point being that I want this side just to be the number. And then I want the right side to just be the variable, so I have to subtract 5 from both sides. So now I have 22 equals 11a, and I want to separate the a so I can solve for a. It's attached to the 11 by multiplication. The inverse of multiplication is division. So what undoes multiplication is division. And then we have 2 equals a. You always want to check your solution. What that means is that you're going to take the value that you found for a, substitute it back into the original equation. If the checked equation balances, then you know you have it correct. One of the benefits, or one of the attributes of mathematics that I've always appreciated, was that you could check your work and know for sure that you got 100%. So 27 minus 6 should equal 16 plus 5. 27 minus 6 is 21, and 16 plus 5 is also 21. That is correct. That is a true statement, so we know A is indeed 2. Number 4, they have 9 times the quantity, C minus 2, is equal to 3C minus 28. So the first thing I look at is the coefficients on the other side of the equation. Should I be distributing that, or can I divide it out right away? Well, 9 won't go evenly into 28, and I really don't want to deal with fractions, so I'm going to opt to distribute. 9 times C is 9C. 9 times, let me get a different color, 9 times 2 is, negative 2 is negative 18, and that should equal 3C minus 28. So now what I want to do is move all the letters to one side, all the numbers or constants to the other. So 3 is smaller than 9, so I'm going to move the 3C over with subtraction. So now I have 6C minus 18 equals negative, don't drop that negative there, negative 28. Now I want to, since the negative 18 is attached to the 6C, I can undo that with the inverse operation of addition. So I'm going to add 18 to both sides. So now I have 6C is equal to negative 10. And then I want to divide both sides by 6 because I want the C just by itself. And now I have C is equal to negative 10 over 6. But I do recognize, I'm going to switch to a different color here, that negative 10 is negative 1 times 2 times 5. And 6 is 2 times 3. And then here you see the 2's will cancel out. You can only do this when there's multiplication between the numbers. So now we can reduce 10/6, negative 10/6, to negative 5. Negative 1 times 5 is negative 5 over 3. And then we check. We have 9 times negative 5 over 3, substituting in that value for C, minus 2, should be equal to 3 times negative 5 over 3 minus 28. Now we have to distribute again. 9 divided by 3 is 3, times negative 5 is negative 15, and 9 times negative 2 is negative 18. So that's equal to negative 33. And then on the other side, 3, when I distribute or multiply the 3 times negative 5/3, the 3's cancel out, so I end up with just negative 5 minus 28, which is negative 33. Since that's a true statement, then I know that C is indeed negative 5/3. Number 5 reads 8 minus 4m equals 2 times the quantity m minus 1 plus 10. So I'm going to distribute the 2 to get 2m minus 2, because negative 1 times 2 is negative 2, plus 10 on the right, and on the left I still have 8 minus 4m. Now, deciding which number or which term to move next, I look at the terms that have the variables in them. If there was another term over here that had a variable in it, I would combine like terms before I would move. But I'm looking at, this is negative 4m, and this is positive 2m. So what I'm probably going to do is add 4m to both sides so that I'm working with positive numbers. And then I can combine these two right away. Now I want to subtract the 8 from both sides. Then I get 0 is equal to 6m. Divide both sides by 6. Remember, you can divide 0 by a number, but you cannot divide by 0. Division by 0 is undefined. So this m is 0. Now I want to check. 8 minus 4 times 0 is just going to be 8. Is equal to 2 times 0 minus 1 plus 10. So 8 is equal to 0 minus 1 would be negative 1. That would be negative 2 plus 10, which is indeed 8. That's true, so our solution here is 0 equals m. So now I'm looking at this rather intricate diagram provided with number 6, where they're showing line DC, line AB, and remember it's a line because it has the 2 arrows, ray EG, which means the endpoint is at E and it goes off in the direction of G, and ray EF intersect at point E. Determine the measure of AEC. So they want to know the measure of this angle over here. Well, I know if two angles are vertical angles, then they are congruent. So I know that angle DEB is congruent to angle CEA, or AEC, and DEB is made up of all of these 3 little angles. So I have 2x plus 2x plus 2x, that's 6x, and then 12, 12, 12, plus 36 make up angle DEB. And then on the other side, I have 11x minus 4. So then what I want to do is subtract the 6x from both sides, and then I get 36 equals 5x minus 4. then I'm going to add the opposite of subtraction is addition, or the inverse operation. I'm going to add 4 to both sides, and then I get 40 equals 5x. When I divide, and yes, you always want to show your work. So even though you might go, oh, 8 times 5 is 40, x equals 8, you still should show that you're dividing by 5. So x equals 8, and then I want to check my work, don't I? Determine the measure of AEC. By the magic of technology, I'm going to shrink this down a little bit. And then I'm going to check. So 6 times 8 plus 36 must be equal to 11 times 8 minus 4. So 6 times 8 is 48, and that will be 84. And then we have 88 minus 4, which is also 84. So that's wonderful. And the nice thing is, when we go to substitute in on this side, 11 times 8 minus 4 is 84 degrees. That was this side of the equation over here. So we actually had it there. Now the verbiage rhetorical style is actually new to me, but we're going to roll with it. And I believe it means in words. And symbols is just like this. So if we were to solve x plus 2x equals 9, the first thing we want to do is combine like terms. So if we have 2 xylophones plus another xylophone, that would give us 3 xylophones. And then we want to divide both sides by 3, and then x equals 3. Check that right away. 3 plus 2 times 3 is 3 plus 6, 9. Yes, it is. We are correct. The following text, which has been translated into English, first appeared on an Egyptian mathematical papyrus that is now housed in a museum in Moscow. Method of calculating a quantity calculated times 2. Together with it, that is, the quantity, has come to 9, which is the quantity that was asked for. So if x equals a quantity, the method of calculating a quantity calculated times 2, so 2x, has come together with it has come to 9. So that's actually the same equation that we just solved up here. I wrote 2x plus x, they have x plus 2x, but they are both going to come to the same outcome. So both are the same, just different ways of asking. So what's different? 7 is symbols. Number 7. Number 8 is words. Why do you think the Egyptian version is written in words? I don't know. I don't know why someone else would do something. Maybe that's just how they did things. Maybe the rationale was similar to me making this video, because it kind of tells you how to solve it, which is what they're getting at in number 9. So in number 9, they're talking about the first line, you shall calculate the sum of the quantity and this 2. So remember we had 2x plus x equals 9. They're talking about maybe rewriting that as 3x equals 9. And then divide 9 by 3. So remember we divided both sides by 3, and we got x is 3. So first line, combine like terms. And then the second line, talks about dividing. And the third line is the solution. Here we're going to get into some literal translation of word problems. This is the handout that I will be providing in class. I'm going to try to slowly scroll through it so that if you need to amend notes, you can, and you should be able to pause as needed. So now I'm going to use a lot of color here. The sum of 13 and twice a number. So the first thing we want to do is define our variable. Let x equal a number. Then the sum of 13 and twice the number. The verb is always your equal sign. Is 7 less than. The less than confuses people. It basically means right backwards. So I'm going to put the 7, whoops, I'm going to put that in blue so it's easier to see. 7 less than means subtract. Let's hope this is a lighter. Running out of colors here. 6 times the number. 6 times the number. Remember, the number was defined as x. So now we have 13 plus 2x equals 6x minus 7. I have 2x here and 6x here. So what I'm going to do is subtract the 2x from both sides. Subtracting the smaller just so I can work with positive numbers. And I have the negative 7 attached to the 4x, so to undo that, I'm going to use the inverse operation of addition and add 7 to both sides. Oops. Then I'm going to divide both sides by 4, and I get x equals 5. So our number is 5. To check, which we should always do, 13 plus 2 times 5 equals 6 times 5 minus 7. So 13 plus 10 equals 30 minus 7. 23 equals 23. And our number is indeed 5. So here they're telling us the measure of A is equal to the measure of B. So I'm going to note that measure of A is equal to the measure of angle B. Then they tell me the measure of angle A is 9 more than. So here I'm going to jump into my colors. 9 more than 6 times a number. So I will have to define my variable. Let x equals a number, and then 9 more than 6 times a number is equal to a, and angle B is 30 less than. Whenever you see the than, remember to write backwards. Up here I did it using a dark purple and light purple. On the bottom I did it just in one swoop. Now it doesn't really matter so much with addition. It absolutely matters with subtraction. And it only absolutely matters if, otherwise with addition, if you're being assessed on a literal translation. So it's just best to make sure it doesn't matter if it's addition or subtraction. Whenever you see the than, write it backwards. Where was I? 30 less than 9 times the number. 9 times the number. And we know angle A, measure of angle A, is equal to the measure of angle B. So now I can say 6x plus 9 equals 9x minus 30. Then I can subtract the 6x from both sides and get 9 equals 3x minus 30. I want to isolate the variable. I want the letter by itself. So I'm going to add 30 to both sides. And now I get 39 equals 3x. Divide both sides by 3, and I get 13 is equal to x. To check it real quick, well, it's asking me what are the measures. If I had set this up to be more of a table, which I'm going to squeeze that in now, 6 times 13 is what? 78 plus 9, which is, I believe, 87 degrees. And then 9 times 13 minus 30. 9 times 13, that's 27. Carry the 2. 1 times 9 is 9. So that's 117 minus 30, which is also 87. So the measure of angle A and the measure of angle B are 87 degrees. Sorry.